You know, there was a time, and it wasn't even that long ago, where if you walked into an SAP project office, there was a very specific way to spot the alpha in the room.
Oh, I know exactly where you're going with this.
You do, don't you? It was the person who didn't need the mouse, the person who could navigate the entire system just by, hammering out transaction codes from memory.
Yep.
If you knew that VA01 was create sales order and VOFM was for formulas, you were practically a wizard.
The walking encyclopedia, that was the archetype. The value of a consultant was, well, it was measured by how many menu paths they had memorized.
Exactly. But today, we're looking at a stack of documents, technical guides, interview prep for senior roles, architectural breakdowns that suggest that era is, well, it's dead, buried.
It is.
If you were still banking your career on memorizing T codes, you might be in trouble.
It's a harsh reality check, but yes. The landscape has shifted right underneath our feet. We are seeing a massive evolution from the functional consultant, the person who just configures the switches, to the technical architect.
And that is the mission for this deep dive. We aren't just skimming the surface today. We are rolling up our sleeves to bridge that gap. We're going to look at the 3 critical pillars that distinguish a junior button pusher from a senior architect in the SAP sales and distribution space.
Right. We're going to cover the nervous system of the business, which is EDI and IDOCs. Then we'll look at what I'd call the brain transplant, that huge shift to FSCM credit management.
A brain transplant, I like that.
And then we'll crawl inside the engine room to see how S/4HANA has physically changed the database tables you used to rely on.
And we are going to finish with some war stories, real-world disasters caused by bad configuration. We're talking about how to debug code when the system lies to you, and how to avoid mistakes that can literally cost a client millions of dollars in a single afternoon.
It sounds dramatic, but in this field, the stakes really are that high. They really are.
So let's start with that nervous system, EDI and IDOCs. Now, I'll be honest, when I hear these terms, I often hear people use them interchangeably. Did the EDI post? Did the IDOC fail? To the layman, aren't they basically the same thing?
That right there is the classic rookie mistake. If you are in a senior interview and you use those terms as synonyms, the interview is essentially over. You have to establish the boundary.
Okay, so draw the line for me. Where does EDI stop and the IDOC begin?
Okay, think of EDI, electronic data interchange, as the language of the outside world. It is the industry standard for transmitting data between different companies.
Little lingua franca.
Exactly. You have specific formats like ANSI X12, which is huge in North America, or EDIFACT, which dominates Europe.
So these are just structured text files.
Effectively, yes. But the key is that EDI is system agnostic. The EDI format doesn't care if you are running SAP Oracle or if you are parsing the data into a spreadsheet on a laptop. It is just the agreed-upon letter that you send through the mail.
Okay, so that's the letter. Where does the IDOC fit in?
The IDOC, the intermediate document, is SAP's proprietary container. It is the internal vehicle. So picture this. The external world sends a letter, the EDI file. It hits your company's mailroom.
And the mailroom is the middleware.
Exactly. Your SAP POPI or a third-party tool like Sterling or MuleSoft. The mailroom opens the envelope. It reads that ANSI X12 language. It translates it into SAP language, and then it stuffs that data into a file folder that fits perfectly into SAP's filing cabinet.
And that file folder?
That file folder is the IDOC.
So the IDOC is purely an SAP concept. It never leaves the SAP world.
100%. Once it crosses the SAP boundary, it is an IDOC. And a senior consultant needs to know that IDOCs aren't only for EDI. We use them for ALE, application link enabling, to move data between 2 different SAP systems, for example.
Oh, okay.
So while all inbound EDI becomes an IDOC, not all IDOCs are EDI.
That is a crucial distinction. Okay, now let's get specific. If I'm an SD consultant, I'm managing the sales cycle. The source material lists the big 4 IDOCs that, run the digital supply chain.
Yeah. These are the bread and butter. If one of these breaks, the physical supply chain can literally stop moving.
The first one is obvious, the inbound order.
Right. The order's message type. This is where it all begins. A customer, say a big retail chain, sends you a purchase order. Your system receives it as an IDOC and attempts to turn it into a sales order, usually by simulating transaction VA01 in the background.
Now, I'm looking at the structure of this IDOC in the notes here. We have these cryptic segment names like E1EDK01 and E1EDP01. Do I really need to memorize these?
You do, and here's why. When a project goes live and orders start failing, you aren't going to be looking at a pretty user interface. You are going to be staring at the raw data structure.
At the raw text.
At the raw text. E1EDK01 is the header data. That's where the customer sends their sold to party or their currency. The K in the middle stands for Kopf, which is German for head.
Okay, header. And E1EDP01.
P for position or item. That's the item data. Material numbers, quantities. If an order fails because the material doesn't exist, you need to dive into E1EDP01 to see exactly what the customer sent. Did they send the right EN code? Did they send their own internal part number that we don't recognize?
So you need to know where to look.
You need to know where the smoking gun is hidden.
Okay, so the order comes in, we successfully create it. What happens next?
The digital handshake. The OR ERSP, the order response.
This is us saying, we got it.
We got it, and we promised to deliver it on this date. It confirms the quantity and the price. Then the process moves to the warehouse. We pick the goods, pack them, and do the PGI, the post-goods issue.
And that PGI triggers the next big one.
It triggers the DSADV.
Dispatch advice.
Or the ASN, the advanced shipping notice. This is probably the most critical document for modern logistics. It flies out to the customer to say, the truck has left the building. Here's the license plate of the truck, and here's exactly what is on every single pallet.
Why is that so critical? I mean, the truck will get there eventually, won't it?
Because modern distribution centers are automated, they're not run by people with clipboards anymore. If that DCDV doesn't arrive before the truck does, the gate won't open. The customer system doesn't know what to do with the goods. I've literally seen trucks turned away because the IDOC was stuck in the system.
That's a physical, literal roadblock caused by a digital failure.
Exactly.
And the last one of the big four.
The NVOIC, the digital bill. No NVOIC IDOC, no payment. It's that simple.
So we have the flow. Orders, order SP, DSAV, invoice-OC. But the guide highlights a specific transaction that it calls the gatekeeper of EDI, WE20, partner profiles. Why does this one transaction get such a dramatic title?
Because WE20 is the security guard. It's the bouncer at the door. You can have the perfect EDI file or perfect network connection and a perfect server. But if WE20 isn't configured for that specific partner, SAP just locks the door. It will simply reject the incoming IDOC.
So what are we actually configuring in there? It sounds like an old school switchboard.
It is. For inbound traffic, like that orders message, you are linking the message type to something called a process code.
A process code, what's that?
Think of the process code as a pointer. It's an instruction. It tells SAP, hey, when you get an orders message from this partner, don't just stare at it. Run this specific function module, this piece of ABAC-E code, to interpret it and create the sales order.
Ah, so it's the what to do with it part.
Exactly. And for outbound, it's even trickier because it connects the business action to the technical output. It links to message control.
Okay, connect the dots for me there.
Okay. You are a user. You create a sales order and you click Save. In the background, the system runs output determination, that's transaction inst, to decide what to do next.
Right.
It decides, okay, send an order response. But how? Fax, email, print. It checks WE20. WE20 says, for this customer, use the IDOC port. If that link in WE20 is missing, the user thinks they sent the confirmation, but it actually never left the system. It just vanished into the ether.
That sounds like a total nightmare to troubleshoot. Which leads us perfectly into the next section, debugging. The guide calls this the detective work.
This is the skill that separates the senior consultants from the people who just take notes and create tickets for the technical team.
Let's set the scene. It's Tuesday morning. An inbound sales order fails. The user sees a red light in the monitor. What is the very first thing you look at?
The status code. The number tells the story. If you see status 51, that means application document not posted.
Translation for the rest of us.
It means the tech worked, the file arrived, the IDOC is sitting comfortably inside SAP, but the business logic rejected it.
So something like material is blocked or credit limit exceeded.
Exactly, or mandatory field missing. It is a functional error. It's not an IT problem. It's a data problem that a functional person has to solve.
Okay, contrast that with status 53.
Status 53 is the green light. Success. The application document, the sales order in this case, was created. Everyone is happy.
Now, I see one here that confuses a lot of people. Status 64.
Status 64. Ready to be processed.
That sounds yellow, like it's in limbo.
It is yellow. And 99% of the time, if an IDOC is stuck in 64, it just means the background job hasn't run yet to pick it up and process it.
So it's not broken.
It's not broken, it's just impatient. You either wait for the job or you push it through manually, but it's not an error.
Okay, back to the red light. Status 51. The order failed. We need to fix it. The source mentions a secret weapon transaction,
Yeah.
WE19. But it implies that most people use it wrong.
They do. They use it as a blunt instrument. WE19 is the test tool. It lets you take a failed IDOC, make a copy, edit the data if you think you found the problem, and then resubmit it.
So you're guessing. You think the plan is wrong, you change it, you fire it off again.
Right. And if it fails again, you guess something else. You're just throwing darts in the dark. You aren't learning anything.
So what is the senior move?
The power move is running it in foreground mode.
Okay, walk us through that. What does that mean?
When you are in W19, there is a button usually labeled Inbound Function Module or Call-in Debugging. When you click that, you aren't just processing the file, you are launching the ABAP debugger.
So you're actually looking at the raw code as it runs.
You are stepping inside the brain of the system. You see the code, that function module we mentioned, IDOS and ptortors line by line. You watch the data flow from the IDOC segment into the program variables. You hit the step button, and you see the system check the plant code.
And if the plant is wrong?
You see it happen live. You see the variable E1EDP01 works come in from the file as 1000. You see the system do a select on table T001W. You see the result of that select come back with a return code of 4, which means not found. And then you see the system trigger the exact error message.
So you aren't saying, I think maybe it's the plant. You are saying, I watched the code reject the plant on line 257.
Precisely. It turns a guessing game into a forensic analysis. It gives you the evidence, the absolute confidence to go back to the client or the trading partner and say, your data is wrong in this specific field, and here is the proof.
That is incredibly powerful. Okay, let's shift gears. We've covered the nervous system, getting the data in and out. Now let's talk about the brain, the decision maker, credit management.
And this is where we see the brain transplant we talked about.
The source material is very, very blunt here. It says, essentially, if you know transaction FD32, forget it. Now, for the listeners, FD32 was the home of credit management for 20 years.
It was. It was the cockpit. You went to FD32, you saw the customer's credit limit, you saw their exposure, you could block them or release them. But in S4ANA, it is gone.
Just gone.
Deleted.
And
Obsolete.
it's-
If you type FD32 into the command bar in an S4 system, you get an error message telling you it's no longer supported.
So where did it go? What replaced it?
We have moved to FSCM, Financial Supply Chain Management.
Why the change? Was the old way broken?
It wasn't broken, but it was monolithic. It was isolated. The old system, based on table KNKK, linked entirely inside that one ERP system. FSCM is built on SOA service-oriented architecture.
Okay, what does that mean in practice?
The philosophy is that credit management should be a centralized service, a credit server that can assess risk for multiple different SAP systems or even non-SAP systems all at once.
So you have one brain controlling the credit for multiple different bodies or companies.
Exactly. It's much more scalable and flexible, and it relies on a completely new master data structure. We aren't really dealing with customers in the old way anymore. We're dealing with business partners, specifically the credit segment within the business partner.
Let's unpack credit segment. How is that different from the old credit control area?
It's about granularity and hierarchy. In the old world, it was very flat. You had one credit limit for a customer in a credit control area. That was it. In FSCM, you have a main segment, usually defined as segment 000, which functions as a global limit.
Okay, a global limit.
But then you can have subsegments for different lines of business or different regions.
Give me an example of how that works in practice.
Okay, say you have a customer who buys both heavy machinery from you and also spare parts. You can set a global limit for them of, say, $1 million. But you can set a specific segment limit for the spare parts business at only $50,000.
So if they stop paying their small bills for spare parts.
You can have the system automatically block the spare parts segment. They can't order any more nuts and bolts, but it doesn't have to stop them from buying a new $1 million machine. It gives the business a scalpel instead of a sledgehammer.
That's really smart. Now, the other big change mentioned here is the calculation engine. In the old days, a credit manager looked at a spreadsheet, decided on a limit, and typed in $50,000.
Right. It was static.
Right.
And in a modern, fast-moving economy, static is dangerous. FSCM introduces formulas.
Formulas, like in Excel.
Pretty much, yeah. You configure the system to calculate the limit automatically. You build a rule, you tell it, take the external credit score we buy from Dun& Bradstreet, add the internal risk class we assign them, factor in the country risk, and compute the limit based on that formula.
So if the customer's external credit rating drops overnight,
The limit in your SAP system can drop instantly. No human intervention needed. It's dynamic, real-time risk assessment.
that sounds incredibly efficient. But I can see a user problem here. It feels like a black box. If I'm a sales rep and my order gets blocked, I used to just go look at the limit. Now a formula blocked it. How do I know why?
That is the #1 complaint during a migration project. The sales team screams, "Why is this blocked? They have cash." The consultant needs to know the troubleshooting tool, which is UKM Monitor.
UKM Monitor. What does that show you?
It allows you to simulate the credit check, but more importantly, it shows you the breakdown of the check rule logic. See, a block isn't always about hitting the dollar limit.
Right.
You might have a rule in your check that says, block this customer if they have any single invoice that is overdue by more than 60 days.
So they might have $1 million in available credit.
But because they ignored one $50 invoice from 2 months ago, the system slams the brakes. Hard.
And you can only see that specific logic in the monitor.
Correct. You'll open the log in UKM Monitor and you'll see the limit check has a green light. It passed. But the oldest open item check has a big red light. It failed. That's how you explain it to the user. You show them the specific rule they broke.
There's a technical gotcha in the notes here regarding FSCM that I found really interesting. It mentions asynchronous updates.
Yes. This is a huge headache for people who are used to the old way. In the old ECC system, everything was synchronous. You save an order, the credit table KNKK updates instantly. Boom. Done.
And in SSCM.
Because it is designed as a separate service, it often uses XML messages in the background to communicate and update the exposure.
So there's a lag, a delay.
Sometimes a lag, or worse, sometimes a failure. Imagine this. You save a sales order for $10,000. The order is created successfully, but the XML message that tells the credit server, hey, add $10,000 to this customer's exposure, fails due to a network glitch.
So the credit server, the brain, thinks the customer owes less than they actually do.
Exactly. The customer could keep buying and buying, blowing past their real credit limit because the brain isn't getting the updates from the body. The exposure is out of sync.
How do you even catch that?
You have to check the SOA monitor, that's transaction SRT-MONI. You have to look for failed XML messages. That is a skill a functional SD consultant never ever needed 10 years ago. Now, if the credit numbers don't add up, that is the first place you have to look.
That is a vital tip. Okay, we've covered the nervous system and the brain. Now let's go deep into the engine room. Section 3. S/4HANA technical changes.
This is the infamous simplification list, which is often SAP speak for, we deleted a bunch of stuff you used to use and you need to relearn how to do your job.
The big headline here is the database diet. Specifically, the removal of tables VBUK and VBUP. Now, for the non-technical listener, why were these two tables so important for so long?
VBUK was the status header table, and VBUP was for items. For 20 years, VBUK was the central nervous system of status management in SD. Every single sales order, every delivery, every invoice, their overall status, open, in process, complete, build, lived in VBUK.
So if I wanted to find all open sales orders, I just queried VBUK.
Right. But here's the problem. Because everything in the sales process went through VBUK to get updated, it became a massive performance bottleneck. Imagine a supermarket with 50 aisles, but only one single checkout lane.
That's VBUK, the one checkout lane.
That's VBUK. Every time you saved an order or created a delivery, the system had to get a lock on that table to update the status. If you had 500 users all trying to save documents at once, they were all fighting for a lock on that one table. It slowed the whole system down.
So in S/4HANA, they didn't just add more checkout lanes, they got rid of it entirely.
They moved the checkout to the end of each aisle. They took the status fields and moved them directly onto the header tables of the documents themselves.
So the status of the sales order now lives in the sales order header table, VBAK.
Exactly. The status of the delivery lives on the delivery header table, LIKP. The status for the invoice is on VBRK.
So no more joins to get a simple status.
No joins. And more importantly, no central locking contention. You read the order, you get the status instantly. It is a massive performance boost.
But There is always a but.
The but is all your custom code. If you have a custom report you wrote 5 years ago that says, select from PBUK,
It just crashes.
it crashes. It stops working completely because the table doesn't exist. You have to go through a huge remediation effort to find all that old code and point it to the new location of the status fields.
Then there's MAT-DOC.
MAT-DOC is the new super table for inventory. In the old days, inventory data was split across two main tables, MKPF for the header and MSIG for the item details.
So you always had to join them.
Always. S4HANA aggregated them into one massive flat table called MAT-DOC. It speeds up inventory reporting and real-time analytics immensely because all the data is in one place.
Let's talk about the end of the customer. We touched on business partners with FSCM, but the guide mentions CVI customer vendor integration. This seems to be a major pain point for migrations.
It is the single biggest cause of delays and headaches in S4HANA brownfield projects. Here's the deal. S4HANA only understands the concept of a business partner. It doesn't really know what a customer is in the old sense.
But wait, standard transactions like VA01 still ask for a customer number? The field is still there.
Exactly. The user interface hasn't changed much, which is confusing, so the system has to have a split personality. That's what CVI does. It is a synchronization bridge.
How does that bridge work?
When you create a business partner in the new mandatory transaction, that's transaction BP, the CVI runs in the background. It takes that BP data and secretly updates the old background tables, like KNA1 for customer general data, so that the standard transactions like VA01 still find the data they expect in the place they expect to find it.
It sounds like a clever magic trick to maintain backwards compatibility.
It is until you mess up the number ranges.
What's the pitfall there?
You have a business partner number and you have a customer number. They are technically two different object IDs. The absolute non-negotiable best practice is to use internal numbering and configure them so they are forced to be the same number. BP 5000 is customer 5000.
I can imagine the chaos if they don't match.
Oh, I've seen it. You have BP 5000 linked to customer 60024. The sales user calls the support desk and says, I'm having a problem with account 5000, but the support rep is looking at customer 5000, which is a totally different company. It is absolute chaos.
So align the numbers. That's the golden rule.
Align the numbers. Do not compromise on this. Fight for it.
Let's look at the pricing architecture.
Yeah.
The source says in big bold letters, KONV is dead.
KONV was the massive transaction data table for pricing conditions. Every price, discount, and tax on every sales order item lived there. It was huge. It's been replaced by a new table called PRC Elements.
Why the change? Is it just a rename?
No, it's all about HANA optimization. KONV had a clustered key structure. It was efficient for old row-based databases. But the HANA database is columnar. It hates clustered tables. It wants flat, transparent tables. PRC Elements is designed and optimized for HANA speed. It also allows for longer field lengths.
Field lengths?
Yes. For example, the material number field is now 40 characters long, up from 18. Currency fields are wider to handle more decimal places. The new table structure supports the modern complexity of business data.
Finally, for the technical changes, output management. We all used to live in NACE and NAST. Now we hear about BRF plus key.
BRF Plus stands for Business Rule Framework Plus. It's the new target architecture from SAP. It uses Adobe Forms for the layouts and these things called decision tables, which look and feel like Excel spreadsheets, to handle the logic instead of the old rigid access sequences.
But the source has a big reality check comment here.
Yes, and this is important. While BRF Plus is the future, NAST, the old way, is still fully supported in S4HANA. And honestly, most brownfield projects where clients are migrating an existing complex system, they stick with NAST.
Why is that? Why not move to the new, better thing?
Because they might have thousands of legacy smart forms and SAP scripts, all their layouts for invoices, delivery notes, order confirmations. Migrating all of those to the new Adobe Forms technology is a massive, expensive project in itself. If it ain't broke, they don't want to fix it.
So as a consultant, you need to know both.
You have to. You need to be able to support the old NAST configuration for existing processes and build new processes using the new BRF Plus framework. You have to be bilingual.
Okay, we have covered a huge amount of ground. We have the theory, we have the architecture. But now I want to get to my favorite part, Section 4, War Stories and Best Practices. This is the Don't Try This at Home segment.
Or rather, please learn from my scars so you don't have to get your own.
Let's start with custom code remediation. We talked about HANA being a columnar database. The guide mentions what it calls the select star sin.
In the old world on an ECC system, the database was row-based. If you wrote select, which means give me all columns for this row, it was considered lazy coding, but it was usually fast enough. The database was designed to grab the whole row anyway.
And in HANA.
In HANA, it's a performance killer. HANA stores data in columns. Column A is stored here. Column B is stored way over there in memory. If you do select on a table with 200 columns, you are forcing the database to go to 200 different memory locations, grab all the bits, and then stitch the full row back together just for you.
So you're actively working against the architecture.
Exactly. You are negating the very speed benefit you upgraded to HANA for. The fix is simple but tedious. Select only the specific fields you actually need. Select Matner, Works, Bibillinen. Be precise.
There's also a trap mentioned here with order by.
Yes. This one is subtle but deadly. In the old database, data often came back sorted by the primary key by default, even if you didn't ask it to. A lot of lazy developers relied on that implicit sorting.
Right, they just assumed the first record returned was the oldest.
In ACA, because of its massively parallel processing, the database grabs data from everywhere at once. The retrieval order is effectively random unless you specify it.
So if your code says grab the first record, assuming it's the oldest one,
you might just get a completely random record, and your business logic breaks in a way that's really hard to debug. You must explicitly write order by in your code now to guarantee the sequence. No exceptions.
I love this next example because it shows how a technical change impacts real-world time. A daily sales report jumped from a 5-minute runtime to 20 minutes after upgrading to the super-fast S/4HANA system. That sounds completely impossible.
It happens more often than you would think. This is a classic code pushdown scenario.
What was the root cause?
The old code had a nested loop. It was looping through thousands of sales orders. And inside that loop, for each and every order, it was doing a select on table BSI to check for that customer's open financial items.
Okay, and why was that so bad in S/4HANA?
Because in S/4HANA, BSide isn't a physical table anymore. It is a calculated view, a compatibility view. It doesn't exist on the disk. It is being calculated on the fly in real time from the massive universal journal table ACDSI.
So the code was asking the system to run a massive, complex calculation thousands of times, once for each order inside a loop.
Exactly. It was bringing the brand new high-powered system to its knees. The calculate on the fly feature is fantastic for a single query, but it is absolutely disastrous inside a loop.
So how did they fix it?
Code pushdown. This is a key concept in ASO. Instead of pulling all the data to the application server and processing it there, you push the logic down to the database. They created a CDS view a core data service.
And what did that do?
It joined the sales order data and the financial data at the database level, letting HANA do all the heavy lifting in one single optimized go. And then the ABIP program just consumed the final pre-calculated result.
And the runtime?
The report went from 20 minutes down to 30 seconds, faster than it ever was on the old system. That is the power of understanding the new architecture. You can't code like it's 2005 anymore.
Now let's talk about the configuration nightmare. This story gave me chills. It's a true P1 disaster.
This is a cautionary tale for everyone listening, seriously.
The story goes, a consultant had a single stuck order in the production system. It was stuck on a credit block, but the business said it was absolutely critical to get it out the door. To fix it quickly, the consultant went to transaction VOV8, the sales document type configuration.
And they went to the sales doc type, and they unchecked the box that says check credit.
Their intention was probably, I'll turn it off, save this one order, and then I'll turn it right back on immediately. A 30-second fix.
But they got distracted. A phone call came in. Someone walked into their office with another urgent problem. They went for a coffee break.
They forgot.
They left check credit turned off. For 4 hours, in the middle of a business day.
Oh, no.
Now remember our EDI discussion? In those 4 hours, automated EDI orders were pouring into the system. Orders from high-risk customers. Orders from customers who were legitimately blocked for non-payment.
And because the global config switch was turned off?
The system simply approved them all. No credit check was performed. It just said, credit approved.
And once an order is confirmed?
The warehouse management system sees them as valid open orders. It printed the dispatch advice, the pick lists were generated, the forklift started moving, trucks were loaded with goods.
So by the time they realized the mistake,
millions of dollars of inventory had left the building, headed to customers who had no intention, or in some cases, no ability to pay for it.
That is genuinely terrifying. What is the lesson there?
The lesson is simple, and you should write it down. Never, ever touch global configuration to fix a transactional data issue. If a single order is stuck, you use the proper transactional workflows. You use VKM3. You create a documented credit decision case. You do not turn off the safety systems for the entire factory just to fix one machine on the assembly line.
That leads us nicely into the concept of impact severity, P1 versus P2. How do you distinguish them when the client is screaming that the sky is falling?
It's all about business continuity. A P1, critical, means production is down and there is no workaround. The business has stopped.
Give me a clear example.
Trucks are physically lined up at the gate, but the post-goods issue transaction is crashing for everyone. Nothing can leave the warehouse. Or invoices cannot be printed system-wide, so cash flow is completely stopped. That is a P1. You wake people up at 2 a.m. for that. You get everyone on a bridge call.
And a P2.
A P2 high is a critical issue, but a workaround exists. For example, the EDI is failing for one specific customer. It's bad, and it needs to be fixed urgently. But the customer service team can manually key those orders in while IT fixes the underlying issue. The business hasn't stopped, it's just slowed down or become inefficient.
That distinction is so vital for keeping your sanity and probably your job.
Absolutely. If everything is a P1, then nothing is a P1.
We have covered a huge amount of ground today. We've really gone end to end. We've traversed the nervous system of IDOCS, the brain of FSCM, and the engine room of the HAN database.
And if there is one single takeaway for you listening, it is this. Being a senior consultant in this new world isn't about memorizing the path in the menu anymore.
No, it's about understanding interdependence. It's knowing that a change you make in the business partner configuration directly impacts the credit check, which in turn impacts the dispatch advice IDOC that goes to the warehouse.
Everything is connected. The plumbing, the IDOCs, the tables, the updates. S4HANA is automating and simplifying a lot of that. The system is getting smarter.
Which brings us to our final provocative thought. If the system is now self-optimizing, if the plumbing is starting to fix itself, the role of the consultant has to shift.
It is shifting. We are moving away from being people who are fixing the system to people who are interpreting the data.
So here's the question for you to mull over. If you aren't needed to fix the broken tables anymore, what is the real value you bring to the client meeting tomorrow? Are you just a technician? Or are you the architect who can explain what the data means for their business strategy going forward?
That is the question that will define the next generation of successful consultants.